All right, here is your review video for all of Unit 1. Just going to run through, again, not every problem, but just some of them, as well as talk about major topics that you need to make sure you understand. So I'm going to start with number 3 because or number 2 rather, because we've got a system of equations there. Seems to be something some people are still struggling with. So we look at number 2. It says you work at a grocery store. Your hourly wage is greater after 6 p.m. than it is during the day. 1 week you work 20 daytime hours and 20 evening hours and earn $280. Another week you work 30 daytime hours and 12 evening hours and earn a total of $276. So the first thing we need to determine when we're going to deal with a word problem is obviously what pieces of information are important. So most of the numbers are generally important. The 6 o'clock is not an important number, but the 20 daytime hours and 20 evening hours, $280, that's one important set, and here is another important set. Now, what we need to note is that we need to write a system of equations. So that means more than one variable, more than one equation. So in this case, since we've got two kind of different pieces, this is going to be a 2-by-2 system, 2 equations, 2 variables that we are going to solve. Also notice, whatever it tells you to find, those are generally your variables. So I want to know my daytime rate and my evening rate. So those are going to be my variables. So I'm going to let D stand for the daytime rate. And I'm going to let E stand for the evening rate. So my first underlined sentence here implies 20 daytime hours, 20 times D, because you worked 20 hours, and D is how much you get paid during the day, plus 20 evening hours, so 20 hours times the amount you get paid in the evening, and then those two things together would earn you $280. On the bottom, we had 30 daytime hours, 12 evening hours, and when we added those together, we earned a total of $276. All right, so solve the system to find your daytime and evening rates. So you can either use substitution or elimination. I don't think one is necessarily easier than the other here. I'll just kind of give you a hint for substitution. If you were going to do substitution, I would subtract the 20e from both sides and then divide by 20 to get D alone, and then we would put that back in here. I'm going to solve this by elimination just because they're nicely lined up in the columns. But again, substitution wouldn't be wrong. If you use the top equation, that should come out pretty nicely. So remember, our objective with elimination is to get opposites on the coefficients of one of our variables. So there's nothing I can multiply 20 by to get 30, and there's nothing I can multiply 12 by to get 20. So I'm going to have to multiply both equations by something, regardless of which variable I choose. I went ahead and went with the D's because I said, well, 30 times 1 is 30, 30 times 2 is 60, and I could get to 60 with a multiple of 20. So I'm going to multiply this one by 2, and this one by -3. It has to be negative because remember, your objective is to get opposites on the coefficients, not the same thing. So go ahead, that gives you -60D minus 60E equals -840. That's what you get when you multiply the -3 times the 280. Then down here, 2 times the 30 is 60, so 60D. 2 times 12 is 24, plus 24E equals 2 times 276, which is 552. So now that I've got opposites on the coefficients, I can add straight down in my columns. So -60 and +24 gives me a -36. E. Negative 840 and positive 552 gives me a negative 288. So divide both sides by negative 36. You should get that E is equal to 8. Once you have that, plug that back into one of my originals. I chose the top one, so I did 20D plus 20 times 8 would be 160 equals 280, and then I solved that for D. So I subtracted the 160 from both sides. So 20D equals 120 divided by 20, and D is 6. Now, it said to find your daytime and evening rates. In word problems, remember you need to write that out. So the rate is $6 per hour for the daytime, because that's what D was. And E is 8, so $8 per hour for evening. If this had been just a straight algebra problem with no words, we would have written our answer as an ordered pair, D comma E. All right, on 3, most people should be able to get A and B pretty easily, so I'm not really going to go into that. I'm going to focus on C. It says use a composition of functions to create a function to find the cost C in dollars of gasoline needed to mow for H hours. Now notice in A and B they told you the names of the functions, G of H and C of G. It says use a composition. We should know what composition looks like by now. But it tells you by what it's asking which composition to do. If you want to find cost C, that means C, which stands for cost, has to be on the outside. So you're going to do C of G of H, because again, this one is going to find C on the outside given hours, which is H in the middle. So in order to do C of G of H, I need to plug some things in. So the answers from here, at least the first part. Sorry, that's hard to read. That's a 2. 2.5H. So C of G of H, again, compositions, outside and work in. So the outside function is my C function. So I do 3.5 times my variable, which is what I'm going to now substitute in here. So G of H is what has to go in the parentheses, and G of H is 2.5H. So this is a composition of functions. I can simplify that by multiplying 3.5 times 2.5. So that gives me 8.75H is my C of G of H function. Units of the domain and range, it already kind of tells you that in the question. But domain is always what we're putting in. So in this case, we're putting in hours. And our range is what we're getting out. What we're getting out over here at the end is cost, which is measured in dollars. All right, use the composite function to determine the cost of gasoline to mow 12 hours. That just means plug in the 12 for the H there. So put that in. Solve that. Make sure you show the work. Don't just write the answer. What is the slope of the composite function and what does it represent? Again, the composite function is this, C of G of H, which we said was 8.75H. So the slope is the number that's attached to the variable here. So the slope is 8.75. What it represents is the cost in dollars per hour. Because we're getting out dollars and we're putting in hours. All right. This we've done quite a few of, and that is real life situations, writing our absolute value. Remember what we said before, that the format for writing an absolute value is variable minus target value inside the absolute value, and on the outside of the absolute value is the amount of variation. So if we're using that we had learned at the beginning of the unit, and again we did it with the Sapphire Island water temperature, the target value is 0.500. So that's what goes on the inside. And I'm just going to put 0.5 because we really don't need to keep those extra zeros, equals the amount of variation allowed, which is 0.15 millimeters. Now, it says write and solve. So this is writing. The solving, I want to make sure you guys understand that this should be intuitive. You should know what the answer is, because if it's allowed to vary 0.15 from this number, that means you're allowed to go 0.15 bigger and 0.15 smaller. So you should be able to do that without even having this. So you should know what the answer should be. Now, the actual solution that you have to show, if you need to work backwards from knowing what the answer is, you can certainly do that. But the work, remember, when I solve an absolute value, I have one that looks just like the original without the bars, and one that needs to be equal to the opposite. So I did that here. So on both of these sides, I'm going to add 0.5. So I get 0.65 here, and then over here, it's positive 0.5 and negative 1.5, so that gives me 0.35. So the extreme acceptable values for the center thickness of the lens are between 0.35 millimeters and 0.65 millimeters. All right. I already spent a good deal of time on the last video talking about these. So if you need help with both of those, you need to check out the review video that I did for the quiz. It's still posted up there on my YouTube site, and the link is still on the website. So the only thing I'm going to say about this is the key is that you have to get the absolute value alone first before you split it. So I split it after I add the 6. So greater than or equal to 10 before I split it into the two separate equations. So again, if you don't know how to do these ones, I'm not going to waste time on this video when I already did it on the last one. So you can check out the last video if you need help with those. 7 and 8. I'm going to skip down again to a blank page here to just go over again how our absolute value functions should look. So our parent function again is the absolute value of x. And what we had done in class is we had written this whole thing out on the board where we had all of these variables. And we talked about what each of them did. So as I talk about what we have in the other equations, I'm going to refer back down to this because this is very important. Again, if there's a negative, that means we need to reflect this in the x-axis. The rest of A controls the vertical shrink or stretch. B controls horizontal shrink or stretch. C controls horizontal translation. And remember, it's important you know which way it horizontally translates. If C is positive, it goes left. If it's negative, it goes right. And D then controls your vertical translation. So positive goes up, negative goes down on that. Now, I've had a lot of people who have come in for help asking about how do I know if it's a vertical stretch or if it's a vertical shrink. So the definitions in your book talk about whether it gets closer or farther away from the axis. Another way to tell, and I think this might help some people, is it's going to be a stretch if the value is greater than 1 on verticals. It's going to be a shrink if it's less than 1. Now, please remember on this that this does not include the negative symbol. If there's a negative out in front here, like let's say it were -5, x, this, you don't say it's a shrink because it's less than 1. That negative has nothing to do with the shrink. That negative represents the reflection in the x-axis. So again, we're only looking at the actual A part, not the sign. So if it's a number that's bigger than 1, it's going to be a stretch. If it's a number that's smaller than 1, such as 2/3, 1/2, 1/4, all of those fractional values, that's a vertical shrink. On horizontal, it works the opposite. And that is on the inside, it's going to be a shrink if it's greater than 1, and a stretch if it's less than 1. Also remember on the horizontal, when you're describing translations, the factor of the shrink or stretch is always the reciprocal of whatever number is in the equation. And of course it works the other way too. If you have the words and you're writing the equation, remember that these ones are reciprocal. Here it stays whatever it is. So if it's a 3 in front, we say by factor 3. But for the horizontal, the factor is always the reciprocal. Remember that both things that are horizontal are inside the bars. Both things that are vertical are on the outside. All right, so looking at some of these, describe the transformations. So when I look at this, I take it a little bit at a time. So I look at this +5 first and I say, okay, that represents a horizontal translation. Where's it going? Plus means left. Left how many? Left 5. This -1, I look at that again. I know because I know this. On the outside, that represents a vertical translation. And since it's negative, I know that my vertical translation is going to go down 1. The only number I haven't described yet is this 3. It's outside, so it's vertical. Because it's bigger than 1, I know it's a stretch. And the factor is 3. On this one, again, I usually start with my translation. So it has a horizontal translation. Because it's negative, I know that goes to the right, so right 2. It has a vertical translation. It's plus, so that means up 4. This 1/3, it's inside the bars, so that means it's horizontal. Again, if you look at what I just went over down here, if it's less than 1, it's a horizontal stretch. Notice the factor has to be the reciprocal. So it's a horizontal stretch by factor, and then I have to do the reciprocal of 1/3, which is 3/1, or 3. Finally, don't forget this negative means something. That means it's a reflection in the x-axis. I had somebody ask me if the order that you list these matters. No, it doesn't matter what order you list them in. I just list them in the same order that I would look at them if I were graphing. Remember that when you graph, the vertical and horizontal stretch or shrinks change the slope. So if I go to graph this one here, I am going to say move my horizontal and vertical translations. That means left 2, up 3. So from my origin, I go left 2 and up 3 for where my vertex would be. 1/4 is the slope. Because it's negative, I know it's reflected, meaning it opens down. So instead of going up 1 right 4, I'm going to go down 1 right 4 and down 1 left 4. So that would be my graph right there. When I'm looking at domain and range, again, it tells you what notation to use here, but you have to know all of them. I usually do interval first, so as I look to the left, so from right to left as I'm looking, I see an arrow going to the left, so it goes on forever. As I look to the right, I've got an arrow going on forever there. On my range, as I look down, these arrows, although they're going down slowly, they are going down, so it goes down to negative infinity. As I look up, there aren't any arrows pointing up. This vertex is my maximum value. There are no y values above that point, so that point would be 3. It's a closed circle, so it would be included. Now, again, it said set notation, so I need to convert this to set notation. So on my domain, all real numbers is what this says. In set notation, reads x such that x is an element of the real numbers. My range starts off the same, only with y, but now I need a restriction because y isn't all real numbers. It's all real numbers up to and including 3. So, meaning the values that are less than or equal to 3. You could also, if you wanted, this part could be written like this if you preferred. So if you wanted to take this out and you put this in instead, that would work as well. All right, piecewise functions, graphing lines here, or remember that you could also make t-charts. So here, the y-intercept is positive 2. I go down 2 and right 3, down to right 3, or up to left 3, up to left 3. Now, breaking point is when x is 3. So I put my finger on the pink dot where x has a value of 3, which would be right here. This should be an open circle, so I'm going to make a big open circle right there. Less than means to the left, so that means I only want to connect the part of the line to the left. Now, I don't have an eraser here, so I can't erase that dot, but I think that you can imagine that. On my bottom piece here, x minus 1, so y-intercept at negative 1, and a slope of 1. So up 1, right 1, all the way across, and also down 1, left 1. Breaking point again is when x is 3, so that's this point right here, this blue dot. This one should be a closed circle because it has the equals, so I make a big closed circle. Greater than is to the right. Ooh, that was sloppy connecting. So again, ignore the extra dots. I don't have the ability to erase on this recording here. So as I look, interval notation for my domain, as I look left, I've got an arrow. As I look right, I've got an arrow. The range, as I look down, there is a stopping point. It's right here. It's where y is 0. This one does not get a bracket like this one would have. It gets a parenthesis because that value has an open circle. It's not included. The upper, as I look up, I do have arrows there, so infinity on that as well. Number 11 is a step function. So the only reminder I'm going to give you on step functions is that the pieces are all horizontal lines and they all have 2 breaking points. So make sure that you have all the open and closed circles that you're supposed to have, but these should be horizontal steps. Graph the system of equations or inequalities. So I'll do one of these two here. This one looks slightly harder because both of them are not in slope-intercept form. So we'll look at this one first. So in order to graph, you need to get y alone first. So subtract x. Y is alone, so now I can graph that. So y-intercept at 1, slope of -1. So down 1, right 1, all the way across, and up 1, left 1, all the way across. So there's my blue line. Then this one, I need to get y alone, so I subtract the 2x first. These cancel. Don't forget to bring the negative sign with you. That's -3y equals -2x plus 12, or 12 minus 2x, whichever way you write it. Now divide by -3. So those cancel. Over on the right side, -2 divided by -3 is 2/3. So y equals 2/3 x. 12 divided by -3 is -4, so -4. So I start down 4, that's my y-intercept, and I go up 2, right 3, up 2, right 3, down 2, left 3, and there is my other line. Remember, it says make your answer clear. So here's work to graph the lines, but my answer is this ordered pair. Now, some of you didn't watch the first video, and I reminded you that on these we studied the classifications. So you need to then say that this solution is consistent because it has a solution, and independent because there's just one. Remember that when there's no solution, we call it inconsistent. When the solution is infinitely many because it's one line, we call those consistent dependent. So 3, -2 should be your answer here. I'm not going to do 13. It's the same type of idea as 12. 14, I'm only going to show you just one little part. When you are graphing inequalities, the difference is that you have to shade. So I'm going to talk just about that middle line there here. So if I want to graph this part, I would subtract the x first. So that would give me 2y is less than -x plus 2. Divide both sides by 2. Those cancel. So y is less than. This is like an implied 1, so that's -1/2 x. 2 divided by 2 is 1. -1/2 x plus 1. So we start off just like we do any other line. We graph the line, y-intercept of 1, slope down 1, right 2, down 1, right 2, so on and so forth. Now, the key is here, the two differences for inequalities is you have to look to whether it's dashed or shaded. So this one does not have the equals, it is a dashed line. So dashed line there. And then we also have to do shading. Less than means that you're going to shade the area below. Now, don't leave your answer just like this. It's not done. You have to graph the other 2 lines and shade them as well. Remember that your final answer here, you don't write a final answer out like we did over here. Making your answer clear on 14 means show clearly where the overlap. So erase the part of the shading that is not an overlap. All right, on 15, I do want to show this one because it gives you a special case. Since I already solved something with elimination, I'm going to use substitution on this one. So it's easiest to get x alone here in this second equation. So add 2y to both sides. So x equals 2y minus 3. And then you take the x out of the other equation, and you put this 2y minus 3 in. So 3 times 2y minus 3 minus 6y equals negative 9. So distribute gives me 6y minus 9 equals negative, not equals, minus 6y equals negative 9. Like terms here that actually cancel, I end up with negative 9 equals negative 9. We talked about this. You learned it in Algebra 1 as well. But remember, if the variables all drop out, both of them, you still have to look more. I get people who always want to write no solution. And sometimes it is no solution. But this one, when they dropped out, what was left was a true statement, which means this isn't no solution. This is infinitely many solutions. It would be no solution if the variables dropped out and we got something like 0 equals negative 9 or 0 equals 5, something along those lines. So if it's a false statement, it's no solution. Here on this one, it's infinitely many solutions. 16, again, this one, it takes a long time, and I already did this on the first video. So if you need to go back and review how to solve a 3x3 system, you need to go back to the Unit 1 quiz review video. So if you need help with a 3x3, do that. All right, next section, I'm just going to pick a couple of these. So again, all this notation means is take the functions that they gave you and perform the operation in the middle. So I'm going to look at h minus g of x and h divided by g of x and then 22. So on h minus g of x is 4 plus 2x, so I take that first. My operation is subtraction. Remember that whenever we do subtraction, we have to use parentheses. My second function is g, so plug that in, 12 minus 4x. And now I need to distribute my negative. So over here, this stays the same, but now I've got a minus 12 and a plus 4 because that negative changes the signs. So like terms, combine them. You should end up with 6x minus, and then 4 minus 12, which is negative 8. So 6x minus 8 is your answer there. Division, when I plug those in here, my g function 12 minus 4x divided by my h function, which is 4 plus 2x. Remember on division, we did this back in lesson 5.1. Number 21, we talked about how you have to simplify by reducing, and the way that we reduce variable expressions is by factoring. So we went over this. You can look back at what we did in 21 if you need to. But on the top, I can factor a 4 out there because 4 is a common factor between 12 and 4. So what do I multiply 4 by to get 12? I would multiply it by 3. What do I multiply 4 by to get negative 4x? It'd be negative x. Remember that if you redistribute something that's factored, it should give you back the original. So you can mentally redistribute to make sure you did it right. Here on the bottom, they have a common factor of 2, so I'll take that out. And now the purpose of doing that is that I can reduce this and this are both divisible by 2, so if you had 4 over 2, you would reduce it to 2 over 1 or just a 2. So that reduces, so my top 2 times 3 minus x over 2 plus x. You could distribute the top back out. You don't have to. So if you have 6 minus 2x over 2 plus x, that is also correct. Now the key on the division ones are this. Note any values that have to be excluded from the domain. We are not allowed to divide by 0. So I take my denominator and I say, well, 4 plus 2x is not allowed to equal 0. So subtract my 4. So 2x not allowed to equal negative 4. Divide by 2. And my excluded value is that x is not allowed to equal negative 2 because again, if it did, I would be dividing by 0, which is a no-no. 22, remember that this notation means the same thing as this. It's a composition. This operator means to compose the functions. So the one closest to the x is the inside function. The one furthest away is the outside function. So whenever we have variables and not actual numbers, we have to start with the outside, work from the outside in. So on h is my outside function, so I'm doing 4 plus 2x. So 4 plus 2, remember we leave a hole where the variable was. What we put into that is my g of x function, which up here is 12 minus 4x. So now I just need to distribute 4 plus 24 minus 8x, and then combine my like terms. So 4 plus 24 is 28. I put my answer in standard form here, negative 8x plus 28. This isn't division, so we don't have to exclude any values from the domain. All right. So I'm going to do 25 because that covers pretty much the ideas in 23 and 24 as well. So find the inverse, then use the definition to prove that they are inverses. So finding the inverse, remember our steps are first, replace the f of x, the function notation, with equation notation. Then we switch the x with the y. So x equals negative 5y plus 3. And then we just solve for y. So to get y alone, first I subtract 3 on both sides. So x minus 3 equals negative 5y. Then I divide by negative 5. Remember that as long as this isn't a fraction down here, you're allowed to leave it like that. But remember, I need to replace that y notation with my f inverse notation. So f inverse of x is x minus 3 over negative 5. Again, if you wanted to simplify that, the equivalent would be negative 1/5 x plus 3/5. So just to make sure if you did it that way that you would have it correct. All right, so next is use the definition to prove. So remember, we prove that they are inverses by showing that f of f inverse equals x and that f inverse of f equals x. Because remember, what inverse functions do when we compose them is give us back out exactly what we put in. So I'm going to do f of f inverse first. Remember, no magic wanding here. Outside function is my original. So my original was negative 5, leave a hole for my x, plus 3. Inside is my inverse function, which is this guy. So I plug that in, x minus 3 over negative 5. We went over one like this in the homework. Remember, you don't have to distribute here because this is multiplication by negative 5. And this is division. Those cancel each other out. Now, don't cross off multiple things in one step. You're not allowed to do that. You have to show what the intermediate step is. So that gives us x minus 3 plus 3, which then in the next step these cancel, and we have equals x. So I'm halfway done with my proof. I've got this part done. So the other part of my proof is I need to show that f inverse of f of x equals x. So f inverse is the outside function this time, so that's this. So leave a hole where the x was. I've got minus 3 over negative 5. In place of the x, this time the inside function is my original, so I'm going to put negative 5x plus 3 on the inside there. So because this is not multiplication, you really don't need the parentheses. The positive 3 and the negative 3 are going to cancel. Your intermediate step looks like this. I still have some people who are trying to cancel the 5's first and write that the next step looks exactly like this one. It doesn't. That's actually mathematically incorrect. It has to look like this. The 5's cancel next, and I have equals x. So I have now done this. I already did that. I have now proved that they are inverses. All right. So hopefully that helps you. If you were having some struggles, please study by doing. Just watching me is better than doing nothing, but it's not enough. Remember that there are all those extra problems at the end of each activity, the extra activity practices. You can go back and redo the problems in your review, redo your homework problems, but please, please, please study by doing, not just by watching this video. All right, good luck. See you later.